Okay, video 2 on the normal distribution. Not quite such a rough guide this time, but it's getting there. Make sure you've watched that previous video, by the way. Okay, we see here from the Australian Bureau of Stats, we've got a graph here, and the graph is the height of Australian males. This was taken in 2012, and it's got your relative frequency and the heights there, and you can see that classic normal distribution shape that we were talking about. And consider that shape and consider if we have the graph of e to the negative x squared. Okay, and look, the shape is the same. Look at that. Now it can be shown that if we take the integral of that same function between negative infinity and infinity, the entire distribution, you get the square root of pi. Okay, I won't be showing that in this video. But you can verify that with technology or something online. Okay, so it'll stand up. Now to become a probability distribution function, a PDF, we need to manipulate that because remember the area or the integral, area under the curve of the integral has to equal 1. So in order to do that, we need some mods. And if we make those mods, we have using Z on purpose here because this is something we'll see in a future video. And basically, if we make these mods and make it 1 over 2 pi times e to the negative a half z squared, we get a full probability distribution function. And that has a mean or an expected value of 0 and a variance of 1. Therefore, in this case, the standard deviation, you remember the variance and the standard deviation is a square root relationship. Take the square root to get the standard deviation. Thus, standard deviation will equal 1 as well. Now, if we make a linear transformation, which I'm not going to show, but basically the linear transformation involves to get our random variable x, this transformation here, and we do some wrangling, we get what we're looking for, and this is actually the normal distribution. Now, it's not essential that you know how this arises. It's nice to know, and I don't want to treat you like a clown, but you end up with this in here. Okay, so for a normally distributed random variable, now we don't necessarily want the mean to always be 0 and the standard deviation equal to 1. It could have other values. So if the mean is mu, which is other values, and the standard deviation is sigma, this is the formula we need to use. Okay, but it does come from the source of it is from those things there. And basically it gives us the probability that the random variable is a or less. And we'll get more into this in the next video. So the focus for this video will be this part here. And coming up, we're going to look at this random variable z. It's coming up. It's called the standard normal distribution. It's a special case which gets used a lot. So again, just focus on that bit for this bit of video, and we're going to look at a quick example. What if we needed to find the PDF, or the probability density function, of a normal distribution, and we know the mean is 100 and the standard deviation is 15. There we have our formula with the appropriate quantities subbed in here. Okay, and we get a function involving e. All right, so that's all we're aiming for at this stage, but we're building our knowledge base with each video.